Let's quickly talk about raster and vector. Remember that vector is points, lines, and polygons, and lines and polygons are made of vertices. Rasters are pixels. Another thing to remember is that raster, each cell just has one value. In points, lines, and polygons, these features can overlap. So say this one feature could be overlapping this green feature. We can convert between raster and vector, and sometimes this is necessary because of the analysis we want to perform. To say, take a linear feature out of raster and make it vector, we just put a point in the center of each cell that is a particular category or value. So we just put points here at the center of each of these, which gives us this. And then we use post-processing to smooth the line or make sure an area or line stays connected. When converting from vector to raster, we can use different algorithms. In these two examples, we have the any cell rule here, where any cell that our line feature touched becomes that line feature in the raster. Or we have a near center rule where a cell only takes on that value or category when that feature goes through the center of the cell. In the case of this linear feature, the any cell rule leads to a continuous and connected line, but it will be much wider, while the near center rule may lead to a disconnected line like here, and it's also much thinner. Ultimately, no matter what, you lose a little bit when you convert in either direction. So which data model is best? Well, that depends on the data and the application. But in general, vector models produce smaller data sets most of the time. This is because the vertices that make up point data sets are lines or polygons often take up less volume than cells in a raster data set. Topological relationships are better handled in vectors. This is how things are connected and have relationships. This is really important for things like routing. You can't just get on the I-5 wherever you cross that cell. You need to know that you have to find the entrance ramp and find out where those line features are connected. Analysis is often simpler in raster data sets, and overlays are more simple in the raster model. Ultimately, you may end up switching between the two depending on your analysis. And the choice of the right data model is a crucial step. Some advantages of raster data is that it's a simple data structure. It's a matrix of cells with values representing a coordinate and sometimes linked to an attribute table. It's a powerful format for advanced spatial and statistical analysis, which we'll talk about later. It gives you the ability to represent continuous surfaces and perform surface analysis. Points, lines, and polygons don't do this very well. And it uniformly stores points, lines, and polygons and surfaces. Everything's in a cell. All those cells are the same size. And it allows you to perform fast overlays with complex data sets. Let's summarize quickly. The selection of a data model plays a crucial role in your GIS project. Each model has pros and cons, and you need to understand them to make the right choice. Luckily, in this class, you won't be making many of those choices. But if you go on to take GIS 2, those choices are vital to doing some of those analyses. In the raster data model, there are decisions that need to be made about how to represent data. What does the cell become? Do you use the near center rule or the winner takes all rule? These decisions are made by the program or you, But you can also automate these through things like machine learning. And you can translate between data models up to a certain degree, but realize that you lose something a little bit when you convert from raster to vector or vice versa. Selection of either data model is a balance between storage and processing complexity.